Assalamu alaikum wa rahmatullahi wa barakatuh. Today we are looking at the section on fertilizers. There are many different types of fertilizers available to supply nutrients to the soil. You get organic fertilizers, which are obtained from plant and animal material, for example, seaweed, mushroom compost, bird droppings, etc. And you get inorganic fertilizer, which you obtain from minerals, and they are manufactured um, from inorganic materials such as urea, potash. They can be made by industry. And in this particular section relating to fertilizers, we're going to have to look at the industry, the Haber process where ammonia is made, the Oswald process, the manufacture of nitric acid, and the contact process, the manufacture of sulfuric acid, because these acids are required in order to make artificial or inorganic fertilizers as we know it today. Now, if you look at fertilizers and if you take any fertilizer that you can buy from the shop, you'll see that the three main ingredients of fertilizer is nitrogen, phosphorus, and potassium. Now, the nitrogen that is used in inorganic fertilizers that we will talk about are examples like ammonium nitrate, for example. A very popular one would be ammonium nitrate, something which we're going to discuss how you're going to manufacture it. So you'll have ammonium nitrate as an example, NaH4, NO3, you get, and then you get phosphorus, and phosphorates are made from phosphates in the soil, and phosphates are mined near Phalaborwa, and basically the phosphorus mines. And here, any type of phosphate or superphosphate that you can get, for example, calcium, hydrogen for H2PO4 twice. So superphosphate is an example of where you can get phosphates from, and potassium can be gained from potassium chloride or other potassium salts like potassium nitrate. So for example, if you use potassium nitrate, you'll be getting potassium and you'll get nitrogen for your nitrates. So these are some examples of inorganic salts that are necessary for fertilizers to give plants nutrients for growth. The ratio that we get, if you look, for example, here, 24, 14, 14 is called the NPK ratio. The ratio is a series of three or more numbers found on the packing of fertilizers. And this shows the proportion in which the nitrogen, phosphorus, and potassium are mixed in the fertilizer. The number found on the ratio are percentages. And sometimes you may get others like sulfur and magnesium as well to give, which tell you what other nutrients are found in the particular fertilizer that's being made. Okay, just to stop there now, we will just look at an example from an exam paper related to this NPK ratio. Before looking at an exam question, I just wanted to highlight one more important factor, and that is if you look at nitrogen, it is important for plant growth, leaves, and green foliage. The phosphorus creates strong roots, as we can see here, and potassium is used for the general healthy growth of the plants. So if you have too much nitrogen or too much nitrogen, then you can have overgrowth of the leaves. If you have too little phosphorus, then the leaves will be weak, etc., etc. So right now, let's just look at a past exam question, and this is taken from the 2008 exemplar, additional exemplar, right? 13.2.1. A farmer stores fertilizer for NPK ratio 4:5:8, 13:5:9. The farmer wants to grow tomatoes and fruit. Explain the meaning of the NPK ratio. It's a ratio showing the percentages of nitrogen, phosphorus, and potassium in the particular fertilizer. Okay, 13.2.2. Which one of these fertilizers must you use? If you look at this NPK, if you look at this one, it's more balanced. This one is too much of NPK. There's too much nitrogen, so it will have overgrowth of foliage or leaves. So he must rather use 4:5:8. 13.2.3. Give a reason for your answer. The other fertilizer is the other fertilizer is too high a percentage of in is a very high percentage of nitrogen, which will overstimulate the leaf growth. Something to that effect. It doesn't have to be exactly as I have said it. 13.3. Overuse of nitrogen-based fertilizers create problems for the environment and users. Name one threat posed by nitrogen-based fertilizers to the environment and one threat posed to humans. For the environment, what happens is that nitrogen seeps into the water, and then that causes eutrophication. And eutrophication creates too much nitrogen in the water, which results in the overgrowth of seaweed, and then the water becomes green, and as a result, the plants become oxygen starved, and as a result, it causes death of plant life in water. So that's the most popular environmental factor. In terms of humans, we can say that nitrogen in the water can cause cancer is one example of the effects on humans. So those are just two examples of how overuse of fertilizers can cause problems in our everyday life. Thank you for your time.